Good morning. Today we're going to see about the dynamics of particle. In that, we'll see a problem by using the kinematic friction concepts and applying the principle of dynamics. Two blocks, A and B of weight 100 Newton and 200 Newton respectively are initially at rest on a 30-degree inclined plane, as shown in the figure. The distance between the blocks is 6 meters. The coefficient of the friction between the block A and the plane is 0.25, and that between the block B and the plane is 0.15. If they are released at the same time, in what time the upper block B reaches the lower block? Before solving the problem, you must understand the question clearly. It is said that in an inclined plane, the two blocks are kept. At initial stage, they are at rest. It is given here. And the inclination of that plane to the ground level is at of 30 degree. Each block is placed at a distance of 6 meters. The coefficient of the block and the plane between the block and the plane is 0.25. Block A and plane, whereas block B and plane is 0.15. If both the blocks are released at the same time, in what time the upper block B reaches the lower block A? At some point of time, from this question, we should understand that both the blocks will meet each other. So we have to find the time taken by the block A to reach the block B. Let's get into the image. Yeah, this was given. The weight of block A is 100 Newton. Weight of block B is 200 Newton. The coefficient of friction between the block A and plane, we can write it as mu A, is 0.25. The coefficient of friction block B and the plane is 0.15. For solving the problem, we have to assume the acceleration for block A, let it be small a suffix capital A. For block B, small a suffix capital B. Then we have to draw the free body diagram for the block A and block B. Let's start drawing the free body diagram for block A. If the block A is at incline, we know that it is the incline here. As already said that the weight of the block will always perpendicular to the ground plane. We have to draw the weight of the block perpendicular to the ground plane. That is WA. Then the normal reaction, NA. Since the block is inclined, the nature is to move in downward directions, the direction of motion in downward directions. So the frictional force FA will act at the contact points. Here this is FA. To find the distance and the time, we have to consider that the system is in dynamic equilibrium. So we have to substitute MA in the opposite direction to the direction of motion. This will be MA. So we have to assume these as the planes, that is the x-axis and y-axis, so that this will be resolved to horizontal axis and vertical axis. For horizontal, we will have WA cos 60. For vertical, we will have W sin 60. We know that this angle, when this angle is 30 degree, it is also will be equal to 30 degree to y-axis. So this will be of 60 degree. So we have taken 60 degree to solve this problem. This is what the free body diagram. Similarly, we have to draw the free body diagram for block B. This is the free body diagram of block B. As already said that the weight of the block will always act perpendicular to the ground plane, and the normal reaction and the frictional force is between the contact plane opposite to the moving directions. Then we have to assume MAB, that is a dynamic equilibrium, moment of inertia. We have to assume to the opposite to the direction of motion. Then we have this WB need to be resolved to horizontal component and vertical component that was written over here. First, initially, we can consider the block B by applying the dynamic equilibrium conditions, and we'll get the unknowns, value for unknowns. By assuming block B, resolving normal force, the force normal to the plane, we'll have 900 NA minus 100 cos 30. This 100 cos 30 can be written as sin 60, as what we have given in the diagram. In few books, it will be written as cos 30. Cos 30 value and sin 60 value will be equal. Since we are resolving to the vertical component, as always, we can keep it as the sin 60, or else we can have it as cos 30. We'll get the NA value as 86.6 Newton. Then resolving the force parallel to the plane, that is along the plane. For this FA, it is in the positive x direction. M, A, that is M, acceleration, mass into acceleration, that is also in the positive direction. W cos t, it is in the negative side of the x-axis. So it is minus. So by substituting all the values, we'll get the acceleration AA value as 2.78 meter per second square. Here the M mass value can be calculated by 100 by, that is given weight by G, W by G. So 100 by 9.81. FA can be written as F is equal to mu into NA. We know that if to find the frictional force, standard formula is mu into NA. So we have calculated the NA value over here. We have to substitute NA and mu value. We'll get the unknown value acceleration as 2.78 meter per second square. Similarly, we have to solve for block B. While we solving for block B, the normal reaction, that is normal to the plane, we resolve vertically. NB minus 200 sin 60 is equal to 0. NB is equal to 200 sin 60, that is values 17.32 Newton. Resolving the forces parallel to the plane, that is FB plus MAB. These two forces are in the positive x directions, acting on the positive x directions when we resolve. Whereas this particular force, while we resolve, it will be travel to the negative x direction. So it is substituted as minus 200 cos 60. We'll, by substituting all the values, FB as mu B into NB, M, for M, the mass 200 divided by 9.81, and we'll get the AB value as 3.63 meter per second square. Then it is given that the object moves from rest. When it starts move, we have to use the equation S is equal to ut plus half at square to find the distance. Let t be the time at which the blocks A and B touches each other. After it released, the block will touch at the distance traveled by the block A and block B will be differ, whereas the time taken to travel the particular distance will be of same. So we can consider t for both the cases. When we substitute that, SA is equal to, we know the initial velocity. Since it starts from rest, it is 0. The acceleration we have calculated for block A and block B, we can substitute SA is equal to 1.38 t square. Here the initial velocity, since the block starts from rest, UA is equal to 0. Acceleration we have calculated for block A, it is 2.78 meter per second square. Then we have to substitute for block B. Here, block B also starts from rest. The initial velocity UB will be of 0. So that we can substitute the acceleration what we have identified. It is of 3.63. So while the block B meets the block A, the total distance traveled by the block B will be SA plus 6. Since the distance between the two blocks is 6 meter, SB have to travel 6 meter, and also the distance traveled by SA, so that the block B will be block A. So SB is equal to SA plus 6. we have calculated the value of for SB and SA. By substituting all these values, we will get the time taken for the block B to meet the block A. The time taken for block B to meet the block A is T is equal to 3.75 seconds. Thank you.